About geometric vectors. So let me get my graph paper here because that really helps me. So we are still talking about geometric vectors. So we're still on 8.1. And what I mean by geometric really is that we're graphing them a lot still. And the next thing we need to talk about is scalar quantities and multiplying by scalars, and then the components. And so on day one, you did have some component work. And if that was confusing, you can go back and do so now. So a quantity, I have a lot of notes again, but not quite as many last time. With magnitude only, is called a scalar. Okay. And things that are scalars: mass, length, time, temperature. Okay. Things that have a magnitude only. So like a number, but doesn't have an angle to it. And then the letter we use is just the cursive letter K. Okay. So the letter we use for scalars is the letter K. And so just a couple of rules here. So if K is greater than 0, then some number K times your vector A makes it bigger. For example, like if this is vector A, then this is vector 2A. And I don't think I made that quite right. I should maybe go a little bit farther. But it's twice the length. Okay, so it goes in the same direction. And it's just double the length. Okay, if your scalar is less than 0, then you take that number, multiply it by A, but in the opposite direction. Okay, so if I have scalar A again, like this, I'm sorry, vector A, then this is negative 2A, for example. So it's twice the distance and going in the exact opposite direction. So similarly, like if I had one like this, then the negative would look like this. Okay, so scalars can make it twice as long, but they don't change the angle unless it's negative, and then it changes the angle to go backwards. So two vectors are parallel. And you might see the shorthand parallel like this. If and only if they have the same or opposite direction. So in this case, the magnitude or the length doesn't matter. So two vectors can be parallel if they're different lengths, but they need to go in the same direction or exactly opposite directions. All right, so next is the part about components. So two or more vectors whose sum, which means you add them, right, is given. Whose sum is a given, can't read my own notes, is a given vector. They're called components. And this really just means we're going to make a triangle. Okay? So that's like the fancy math way of saying make a triangle. So we can express any vector. Any vector as the sum of two perpendicular vectors. And here's where we're going to make a triangle. So if I have a vector, let's call it vector, I don't know, S here. I can express this as, and let me grab two different colors here, the horizontal component and the vertical component. Okay, this would be my angle theta here. So I can tell you if this is, it goes 2 this way and 2 this way, then I can express it as, the square root of 2 squared plus 2 squared. Look at that. We're back to some of this again, so the Pythagorean theorem. So how do we kind of do that in terms of what I'm asking you to do on your homework and your notes? So I'm going to do a couple different examples here real quick. I'm just going to make one up, actually. So if I give you a vector that said let's say 5 centimeters and 25 degrees. If I wanted to find the x value here, hoping that you remember SOHCAHTOA, and I'm going to just color this one different just for now. If I had my angle 25 and I was trying to find the adjacent side, I could use SOHCAHTOA, so cosine, right, because I have adjacent, of 25 equals adjacent over hypotenuse. And you guys could do this, right? You could type in 5 times cosine 25 and get this distance here. Similarly, for the y value here, finding the vertical component, you could use sine. So sine of 25 would be y over 5. And then if you wanted to simplify it, you could just type this in. Okay. So since I'm using my screen recording, I think I could use my calculator to go 5 cosine 25. I think it has this on it. So 5, and you should be in degrees if you're using degrees. 5, and then cosine 25. That's not working out well, is it? To clear this off. If I go cosine of 25, let's see how that works. Do I have to type in 25 first? Cosine, and then we'd hit times 5 equals, so I got 4.53. So my x value would be 4.53. And then we'll do the same for sine. So 25 sine of that. And we'll multiply times 5. And we get 2.1. So I have now found the vertical and horizontal distances that represent my angle of 5 centimeters, or my vector of angle 25 degrees, 5 centimeters long. If I had to travel along a circle, not a circle, but a coordinate plane, I would move 4.53 to the right and up 2.1. So the last example I want to show you is a word problem. And so we're going to say like a cruise ship leaves port and sails 80 miles in a direction 50 degrees north of due east. Find the vertical and horizontal components. All right, so a lot is happening here. I'm going to draw a picture. And so something that I find helpful for me, and you guys all have one of these, like never eat soggy waffles, whatever your little thing is to remember north, south, east, and west. But just thinking about what these directions mean all the time. So it says 50 degrees north of due east. So if I start east and then move up 50 degrees, okay, that is where my angle will be. So since I started at east and moved up towards north, that's where my angle is. Okay, it sails at 80 miles per hour, 80 miles is the distance. So that's like the magnitude, and the direction is 50. So if I want to find the vertical and horizontal components of this, To find the x value, I would use cosine. So x is going to be 80 cosine 50. And I'm going to, for my y value, use sine. So 80 sine 50. And you're going to type both of these in your calculator. And when I did this, I got, for my component, my x component, I got 51.4 miles. And for my y component, I got 61.3 miles. Okay, so you can use sine and cosine to find the x and y components of all of these. So nothing that you haven't done before makes a right triangle, but it's nice to remember, and maybe put this in your notes, that the y value is always the magnitude times the sine of your theta. And the x value is always the magnitude times the cosine of your theta. And you could also, I told you about this, like y equals the magnitude sine theta is another way to write it. Because we talked about yesterday that those absolute value marks mean magnitude. Magnitude is the distance or the length, and the direction is the angle. And so you should be able to do all of the parts of the first two worksheets where you're drawing. You can use patty paper and the tip to tail method. And it's asking you for some of the components of them. So then you will need to use sine and cosine.